Hi, I am Ben Rohr, and this is my final video project for Physics 122. And we're going to be taking a look at Newton's third law and the conservation of momentum. So the conservation of momentum is given by this equation. The mass of some object A times its initial velocity plus the mass of some object B times its initial velocity is going to equal that mass of A times its final velocity plus that mass B times its final velocity. In our experiment, the bobs in the cradle, so we've got A and B, are shown here. So A is on the left, B is on the right. Now, assuming that these bobs are the same mass, which they should be, we can drop the mass out of the equation altogether, and we get the initial velocity of object A plus the initial velocity of object B is going to equal the sum of the final velocities for both of those objects. So, in the cradle, what happens is when you raise one of these bobs up and it gains some height, it has potential energy equal to its mass times the gravitational constant g times the height. And as it comes back down in this direction towards equilibrium, all of that potential energy is converted into kinetic energy, and at that point of the collision, which is at the equilibrium point for both of these bobs, the force exerted by, let's say if this bob B is moving this way and this collision happens, the force exerted by bob B onto A is going to be equal and opposite to the force of bob A on B. And because these masses are the same, and it's simulating as if this bob is moving in a linear direction in a frictionless plane towards this, and because they're equal in mass, what's going to happen is the bob that is moving initially is going to come to rest relative to the bob that's hitting, and this bob is going to continue with the momentum of this bob. So this momentum is going to become zero, and this momentum is going to become what the momentum was of this bob just before this collision. And so it's going to raise this way, and then as it comes back down, the same thing's going to happen, but in the opposite direction. So let's take a look here. I'm going to record just this happening. And notice that the bob, see, this isn't perfect either. It's supposed to simulate it pretty closely, but the steel, it still compresses a little bit. There's some torque in the pendulum as well, so the mass isn't, or the energy is conserved, but the momentum is conserved, but it's not a perfect collision. But notice, so when you pull one back and it hits, in those early ones especially, you can see that that first bob comes to rest as the second bob moves in the direction that it was hit. All right, so examples of this in different parts of life. I mean, the conservation of momentum is seen pretty much everywhere. When somebody hits a baseball with a baseball bat, the momentum of the swinging baseball bat causes the ball that's moving, towards the bat to move away, because the mass of the bat is greater and the velocity is and the momentum is transferred to the ball, and it moves in the opposite direction that it was hit. And yeah. And in any Newton's third law can be observed anywhere. Like if you're standing on the ground, you're exerting that same force down as it is upward. It's very rare, though, that you can see something so perfectly, it's such a perfect example of it as a Newton's cradle, because very rarely do you have something hitting one object hitting another object in a perfectly linear way that are the exact same mass, where one can come to rest and one can move. So that's why the Newton's cradle is an interesting way to observe it with the naked eye, because you can see one stop and one keep moving.